This is for microeconomics. I'm going to go over the solution of question 11 for Module 5 quiz. This question is about profit maximization using the total cost and the total revenue curves. How do we know when profit is maximized, right? We need to figure out our marginal revenue, our marginal cost by using our total cost and total revenue curves. So the total cost curve is already given in the chart below. We need to figure out our total revenue. In this case, for my question, it says, suppose Sienna operates a handicraft pop-up retail shop that sells cardigans. Assume a perfectly competitive market structure for cardigans with a market price equal to $20 per cardigan. The following graph shows Iana's total cost curve. Use the blue points, which is this, the total revenue, to plot total revenue, and the green points, so the triangle symbol, to plot the profit for cardigans for quantities 0 through 7, including 0 and 7. So the total revenue for 0 cardigans is obviously going to be 0 because you're not selling any. So I'm going to get the total revenue dot and I'm going to drag it to the 0, 0 point. Now for one cardigan, I'm going to get $20 because that is the price, right? Total revenue is price times quantity. So for one cardigan, my total revenue is going to be $20. So I'm going to drag it here. I'm going to find the 120 point. It can be a little tricky sometimes. There you go. I found it. The second point is 2 cardigans, $20 each. It'll be $2 and $40. So I'm going to find the 2 and the 40 point. Now this can be a little tricky because as you can see, I overlapped my total cost curve, but it doesn't matter. As long as I know, and now I can't move it anymore. There we go. So at 240. 3 cardigans, $20. 3 times 20 is 60. So I'm going to find my 3 and 60 point. 4 cardigans, $20. 4 times 2 is 8, so $80. At 5, I'm going to find it at 100, right? 5 times 20. 6 cardigans times 20 is 120, so 6 and 120. 7 and 140. I found my total revenue curve. Now what I need to do is find my total profit. Total profit is total cost minus total revenue, right? Total revenue minus total cost. And I'll have my profit. So the revenue is 0 here, and my total cost is 20. So 0 minus 20 will be minus 20. So my profit will have to go at the 0 point at minus 20. My second point here, I have a total revenue of 20 and a total cost of 35. 20 minus 35 is going to be minus 15. So my total profit is here 1 minus 15. At 2 cardigans, my total revenue was $40, and if I move this a little bit, I can see it. My total cost was also $40, so here my profit is going to be 0 on the number 2. At 3 cardigans, my cost is 45, and my revenue is 60. I'm starting to make a profit. So 60 minus 45 is 15. Again here, 55 and 80. So 80 minus 55 is going to be 25. So 4 and 25. And then my total revenue is 100 minus my total cost of 70. That's 30. So the quantity of 5, I'm going to put this on 30. Now, obviously, your numbers are going to be a little different, but this is the path, the steps that you need to follow to build this chart. At a quantity of 6, I have a total revenue of 120 minus a total cost of 95. So that's 25. So 6 and 25. And then at 7, I have a total revenue of 140, a total cost of 125. So that will be profit of 15. And I've built my total revenue curve and I've built my profits curve. So now I can move on. This is the first part. Calculate Jana's marginal revenue and marginal cost for the first 7 cardigans they produce and plot them on the following graph. Use the blue points to point marginal revenue and the orange points to plot marginal costs for each quantity. So we know, let's do marginal revenue first because it's the round dots. We know marginal revenue is the change in revenue divided by the change in quantity. In this specific example, the change in quantity is always 1 because it goes from 0 to 1, 1 to 2, 2 to 3. So it's fairly intuitive, right? So we don't need to worry about dividing by the quantity in this case because it's always 1. All we need to find is the change in total revenue. So from a quantity of 0 to 1 cardigan, the change in total revenue is $20. So our first point between 0 and 1 will be 0 and 1, 20. And so we're going to put the dot between at 0.5 because it's the marginal revenue of going from 0 quantity to 1 in the middle. And that change is $20. The second point is going from 1 cardigan to 2 cardigans. So we go from 20 to 40. That's another change of 20, right? So our marginal revenue again is going to be 20 and 0.5. Now what is happening? We're in a competitive market. We know that the marginal revenue in a competitive market equals the price and equals the average revenue. And we know that it's a horizontal line at the level of the price. So in this case, we know the price is 20. Our marginal revenue is going to be a horizontal line at 20. And I'm just calculating it to show you that that is true. And in fact, if we go from 2 to 3, we're increasing from 40 to 60. The change in marginal revenue is still 20. So we won't calculate every point. We just know that we can drag this in between the numbers. See 4.5 at the level of $20, 5.5 and 6.5, from 6 to 7 because we said 7 was the maximum. Now we can calculate a marginal cost. The marginal cost is not quite as easy because we really have to calculate it. So the marginal cost, we know the fixed cost is the $20, right? The marginal cost from 0 to 1, the cost changed from $20 to 35. So the change in total cost was $15 divided 1 is 15, right? So our first marginal cost will be at 15, 0.5, 15. The second dot is from 1 to 2 cardigans. It was 35 to 40, so that was only 5, the change. So we're going to put 5 between 1 and 2, 1.5 and 5. From 2 to 3, the change was from 40 to 45, so that's 5 again. So we're going to do 5 here. Then we have to do from 3 to 4. It's going to be from 45 to 55. So the change is 55 minus 45 is 10. So we do 3.5 and 10. There we go. From 4 to 5 is 55 to 70. So that's 15, the difference, 70 minus 55. So from 4 to 5, 4.5 and 15. 5 to 6, we have 70 till 95. So 95 minus 70, that's 25. So we're going to do 5.5 and 25. And then from 6 to 7, it's 95 to 125. So 125 minus 95 is 30. So we're going to go down here. We're going to do 6.5 and 30. Now I can already see here where marginal cost intersects marginal revenue. And for me, it's right on the line here where 5 is. Now, what's going to happen, though? If I produce 6, go from 5 to 6, my marginal cost is higher than my marginal revenue, so I'm not going to do that. And if I produce from 3 to 4, I'm still below. I'm going to go from 4 to 5. And my marginal cost is below my marginal revenue, so I'm still good, right? I'm still going to make a profit. So Ivana's profit is maximized when they produce a total of 5 cardigans, because we said here that this quantity, and actually they're going to produce, at this quantity, the marginal cost of the final cardigan they produce is going to be $15. So we're going to look at that point that says going from 4 to 5, the marginal cost was 15, right? Whoops, what did I do here? I ruined my my dot. Whoops. Okay, I need to redraw my curve because that didn't work. So 415, 525, and 630. Perfect. So my marginal cost we said was 15. I clicked on 4 to 5, it was 15. An amount that is less than the price received for each cardigan, because the price we receive is $20. We know it from the question, and we know it because our marginal revenue is $20. At this point, the marginal cost of producing one more cardigan, so going from 5 to 6, the marginal cost would have been $25, right? Would be $25, and it's an amount greater than the price received for each cardigan they sell, because 25 is greater than 20, and therefore Jana's profit maximization quantity occurs at the point of intersection between the marginal cost and the marginal revenue, because that is our efficient level of production for competitive markets. And because Jana is a price taker, she can't decide the price. The previous condition, saying that the marginal cost equals the marginal revenue, is like saying that the marginal cost equals our price, right? Because marginal revenue equals price. So if we produce at the point where marginal cost intersects marginal revenue, then we can also say that the marginal cost equals the price. We're going to grade it, and it all came out fine. And this was the solution to this question.